Alma-X is a student association widely spread over the territory of the Emilia-Romagna region, between the cities of Bologna, Forlì and Cesena. We are currently 35 active members divided in different groups, taking care of all aspects, from technical design to software solutions and marketing. Robotics division, dedicated to the control of the robotic manipulator and its handling during maintenance tasks. Navigation division, working on the driving algorithms of the rover with the primary goal of refining the autonomous navigation routines. Science division, which involves a group of geology students gathering information on the Mars surface and planning our mission for the science task. Vehicle dynamics division, working on the CAD model of our rover and the realization and the control of the adaptive suspensions. Data analysis division, which manages the general controller and does the duty to keep all the information flow between all other subsystems working. Every person on the team has a strong drive in regards to science and the development of technologies for space exploration. Working in Alma-X grants the possibilities for each and everyone to test the skills they have learned in an ever-growing environment filled with challenges and difficulties to overcome. We worked very hard during past months and successfully simulated most aspects of the competition, posing and solving specific experiments. We have gained a strong knowledge of the ROS environment and computer vision libraries. We brought most of our attention to the implementation of the software that could lead to the full autonomous operation. The science task consists in planning the best trajectory in the Mars field to acquire as many images as possible in order to write a short description about the geological history of the area. We used QGIS software to produce the geological map of the Mars yard. In this way, we will be able to highlight the main geological features. For the relative age, we will mainly use the principle of superposition applied on the geomorphological units to figure out the relative ages of any given morphology compared to another one. The navigation division worked in strict contact with the science division in order to produce the best possible path for the navigation task. ERC map is our first means of exploring the environment and can produce a detailed 3D map that can be used later both for navigation and science purposes. We are working on a landmark-based navigation that will be used to precisely reach an on-way point and run in parallel to ERC map. The robotics division tried to implement full autonomous operation, using the RUCO tags to differentiate space position and related tasks, a very important feature of the panel. We had coded a library of actions, each one related to one or more tags. The arm starts by exploring the environment to differentiate all the tags you can find with respect to the robot base frame and to the related action. To lower code complexity level, we implemented a finite state machine using FlexB library. Lastly, we are using the markers of the panel geometries to construct a collision map. Limit the planes delimited where robots should not go and safe zones, offset of the previous, where the robot behavior must change, using a more precise planning.